Hello all, my name is Ashutosh Rastogi. I'm a teacher by profession. My mission is to impart quality education for all. For that purpose, I'm creating these videos. If you appreciate my work, then please do like my video and subscribe my channel so that I could get the motivation to prepare more videos.
Anyways, today in this particular lecture, we will going to discuss about multiple access techniques, in which we will going to discuss about FDMA, TDMA and CDMA. So these are the outlines. We'll start up with the introduction. Then we will going to discuss about multiple access environment. What do we mean by multiple access environment? Then we will going to discuss the classification of multiple access techniques such as your contention based protocols and your contention free protocols. Then we will going to discuss about channelization, which is nothing but your contention free protocol, in which we will going to discuss about FDMA, TDMA and CDMA. And finally, we will going to conclude this lecture via comparing FDMA, TDMA and CDMA. So in a wireless environment where most of the mobile users are trying to transmit their signals, it is difficult to provide interference-free transmission. So obviously, if we are talking about common medium and we are talking about there are multiple users present in the same scenario and they are transmitting over some frequency ranges, then obviously interference might get alter our transmission. So how can we provide interference-free transmission? So the solution is multiple access techniques. So before we discuss about various multiple access techniques and how do they actually work, let us understand about multiple access environment. So this particular figure is showing the multiple access environment. Here we will be having a base station whose coverage would have been called as your cell, and there are multiple mobile subscribers which are trying to exchange their information with the help of these base stations. These red lines are basically representing a kind of links. Through these links, our mobile users will try to exchange their information with the base station. So obviously we could say that there is a base station and there is a common environment in which multiple users or mobile users are competing for their information exchange. So they are basically competing in order to get the link so that they could be in a state to transmit their information as well as receive their information from the base station. So obviously all of the mobile users are dependent for their communication system over this base station. So obviously all these mobile stations want to transmit their information as well as receive their information in the common medium. So wireless multiple access environment basically describing a situation where multiple mobile users are competing to take the access of the link in the common medium in order to inter-exchange their information, obviously in interference limited environment. So if we talk about our multiple access techniques, so these are specific techniques which can be implemented in our multiple access environment in order to provide the interference free environment for inter-exchange of the information among the users. So now we will going to discuss about multiple access techniques. So what are they? Multiple access schemes allow many mobile users to share a finite amount of radio spectrum in efficient manner. So obviously we are talking about a common radio spectrum. So how we will going to use that common radio spectrum in an efficient manner so that the requirement of communication of all the mobile users would have been accomplished in the interference limited environment. So depending upon whether there exists any conflict or not among the various users, we can classify multiple access techniques into two types. So what do we mean by conflict? By conflict we mean that simultaneously when two or more users will going to transmit their information might get garbled up due to the interference. We can classify our multiple access techniques into two types. Number one is your contention based, or we could say that conflicting. The word of conflicting we have already described. And second one is your contentionless or conflict free. So by contentionless or conflict free, we mean that there will not going to exist any sort of collision or conflict among any two users, or we could say that the signal exchange will going to take place in our interference free environment. So some of the examples of our contention based or conflicting protocols are Aloha, slotted Aloha, persistent P Aloha, etc. But now in this particular lecture, we will only going to discuss about contentionless or conflict free protocols. So conflict free multiple access techniques can be implemented with the help of channelization. So by channelization we mean that how we will going to divide our common physical medium so that we can provide interference free environment for the multiple users which are using that common channel. There are basically three dimensions by which we can divide our channel so that the signal will not going to interfere with each other. These signal dimensions are your frequency, time and code. So what do we going to do in our channelization process is we will going to divide our complete bigger channel into smaller portions of such elements or signaling units such as its frequency, time, code, and we will going to provide a smaller portion to each and individual user for their information exchange. So if multiple users are exploiting those channel units for their signal transmission, so their signal will not going to garble or their signal will not going to overlap with each other, or we could say that we have implemented interference free environment for signal transmission. So examples of channelization are your frequency division multiple access, your time division multiple access. Third one is your spread spectrum multiple access. The example of spread spectrum multiple access is your code division multiple access. So in our frequency division multiple access, we are basically dividing the frequencies into multiple subbands, whereas in the time division multiplexing, we will going to divide the complete channel into different time slots, and in the code division multiple access, we are dividing our common medium into different orthogonal codes. So now we're going to start up with your FDMA. It is your frequency division multiple access. So what we're going to do in our frequency division multiple access is we will going to divide the complete frequency band, or we could say that the channel spectrum, into number of non-overlapping frequency bands with some guard band. So we will going to divide our complete frequency spectrum into subbands which are non-overlapping, and we will also providing certain spaces in terms of frequencies between any two frequency subbands where we will not going to transmit any amount of information. So these particular frequency ranges over which we are not at all transmitting any of the information would have been called as your guard band. The use of our guard band is it will basically going to prevent the interference. So each station is assigned a fixed frequency band. Then we will going to provide each of the user to a fixed frequency band. So here by station we mean a user. Then each channel occupies the same frequency band all the time. So whatever frequency band would have been assigned to an individual user, it will going to use the same frequency band all the time for its transmission or for its communication purpose. So receiver should tune to the same frequency band to receive the signal. So obviously in order to receive the signal generated by the transmitter, receiver should tune over the same frequency band over which transmitter is transmitting so that it could properly receive the signal. So the example would have been considered as your FM broadcast communication system, where we have to tune in over certain frequency bands such as 91.1 or 93.5 in order to extract that information signal. So this particular figure is showing the working of frequency division multiple access. So this particular figure is showing the three signal dimensions, that is your frequency, code and time. So in frequency division multiplexing, what we have to do is we have to divide our available frequency bands into multiple subbands. So in this particular example, we are assuming that there are existing 6 number of users, that is your K1, K2, K3, K4, K5 and K6. So we have divided our complete available spectrum or frequency band into 6 equal number of parts, and we had also provided a separation between any two consecutive users frequency subband. So here in this particular figure, it is quite clear that for all the users, that is your K1, K2 up to K6, only a smaller portion of frequency band is available for all the users for the complete duration of time. So this is what we are actually doing in your frequency division multiple access techniques. You can correlate it with your frequency division multiplexing. So when we will going to combine our signal to use the common medium, in that particular case, that process would have been called as your frequency division multiplexing. And when we will going to try to access the common medium in order to fetch our own information, then that particular scenario is being called as your frequency division multiple access technique. So in broader context, you could also say that multiple access techniques would have been implemented in conjunction with multiplexing. It can be used for both, that is analog as well as the digital transmissions. So I mean for analog as well as digital, both type of transmission systems can use frequency division multiple access. So the advantages of FDMA systems are, all the users can transmit their information all the time without waiting for their turn. This is what we had already seen from the last figure, where the sub-band frequencies are available for the individual users, that is your K1, K2 up to K6. Those sub-band frequencies will be available to all the users all the time. That is, whenever they want, they can transmit their information. Second advantage is no dynamic coordination is required. Since we have fixed the sub-carrier frequencies to each and individual users, so there will be no dynamic coordination required. I mean, if there is a reservation for each and every user that which particular frequency will have been accessed by that particular user, there will be no requirement of any sort of dynamic coordination since we have implemented a static system. So the disadvantages of FDMA are it is inflexible and inefficient if channel load is dynamic and uneven. So obviously, if we have implemented an static mechanism to access or share the medium, in that essence, it is not flexible, it has become static, and the functionality would become inefficient if the user is generating a traffic which is uneven. That is, at certain time it is generating more amount of information, and at certain instant it is generating lower amount of information, and even there are some times where it is not at all generating any sort of information. So during the time when the user is not at all generating any sort of information, then also we have provided those frequency bands to that user, which is inefficient utilization of available spectrum. Adjacent channel interference is present in spite of providing guard bands. So although we are providing guard bands in order to avoid the interference, but then also adjacent channel interference present in our FDMA systems due to the non-ideal characteristics of the filters. So the application of FDMA are each channel gets a band or range of frequencies used in traditional radio, TV, etc. So these are some of the applications where FDMA systems would have been used. Traditional radio example we had already given. Television broadcast is also one of the example of your FDMA systems. So FDMA is also present in various wireless communication standards such as your AMPS, CT2, DECT, etc. So where this AMPS, Advanced Mobile Phone Systems, is a 1G standard for your cellular communication systems, whereas cordless telephony 2 and digitally enhanced cordless telephony are the examples of your second generation systems. So now the next technique is your time division multiple access. So TDMA is called as your time division multiple access. So what we are going to do in our time division multiple access environment is each user can access the channel in rounds. That is, we will not provide the access to each and every user for all the time, although we are providing the access of complete channel for a smaller duration of time. That is why we are saying that we are providing access to the channel in round. In a complete one round, user get a smaller duration of time in which it can access the complete frequency band. Each user gets fixed length slot. So this is fixed length slot or timing slot I'm talking about in each round. So in each round, individual user will going to get a smaller amount of time where it is allowed to transmit its information. So we have written length slot as length is equal to packet transmission time, just because time division multiple access system would have been used in our digital communication system where we are transmitting our information in the forms of packet. So during that time slot, individual user must have to transmit its complete information. That is why we have written that. So each user can transmit the signal using same frequency but at different time. So here what important point is each and every individual user can transmit the signal using the same frequency but at different time. It means all the user can using the same frequency band, but since they are present at the different time, so this is how we are trying to avoid the interference. So entire bandwidth is available to the user, but only for the small duration of time, that is the time slot duration. Another important point about your TDMA is in this particular scenario, the complete bandwidth is made available to the user, but not for all the time. It is only limited to the smaller duration of time within that round. So in single round, it will going to get only small duration where it could transmit or receive its information. So this particular figure is showing the working of your time division multiple access. Again, these are three dimensions such as your code, frequency and time. We are again assuming that 6 number of users are trying to access the environment. But here what we are doing is we are dividing the time access into equal number of parts. and we are also putting some time difference between two consecutive time slots. So this particular time duration would have been called as your guard band. So guard band are there to prevent the overlapping of consecutive users signal due to the timing mismatch. So here from this particular figure, it is also being clear that in this particular multiple access techniques, all the frequency band is made available to each and every individual user, that is your K1, K2, K3 up to K6. But here the condition is that complete frequency band is made available to the user, but only for a smaller duration of time. So this is how your TDMA system functions. So some of the advantages are it can assign more time to the sender with heavier load. So as we have already discussed that the major disadvantage of FDMA system is it is not doing well, or it is not functioning well when user is having uneven loads. So what we can do in our TDMA system is we could give more number of time slots or more amount of time for individual user, which is generating higher amount of traffic. So this is the advantage of your TDMA system. There is no need of precise narrowband filter as we are required in our FDMA systems in order to avoid the overlapping of two neighboring channels or users who are using neighboring frequencies. Since TDMA is functional on the philosophy of buffer and burst, so it will going to buffer the amount of information and it will going to generate burst amount of traffic when it has got its turn or time slot. So by this manner we could say that it can save more amount of power since it is not supposed to transmit all the time. It is also having higher capacity in comparison to FDMA system. So in our last slide we had already seen that the typical capacity of TDMA systems is m times larger than your FDMA systems, where m is the number of users that we can attain in a single subchannel. So now the disadvantages. So the major disadvantages of your TDMA systems are it requires timing synchronization. Since if timing synchronization is not there, then obviously the contiguous slots user data will going to overlap with each other and interference will going to happen. So that is why it is requiring very high timing synchronization, else the functionality of TDMA will going to affect. So now we're going to discuss the applications of TDMA. So TDMA is used in 2G cellular systems. As we had already discussed, it is used in our digital communication systems. So TDMA is used in 2G cellular systems such as your GSM. You could say that your global system for mobile communication, Interim Standard 136, personal digital cellular, which is also called as PDC in short form, and IDEN, that is your integrated digitally enhanced network, and in digital enhanced cordless telecommunication system standards for portable phones. So in all those communication systems for multiple access environment, TDMA would have been employed. So these are the application areas of your TDMA. So now we will going to discuss about CDMA. CDMA stands for Code Division Multiple Access. All users uses the same frequency, but each user has its own chipping sequence, or you could say its coded sequence by which it will going to encode its information. So how encoding process will going to take place in CDMA system is encoded data will be equal to chipping sequence into original data. So what we will going to do that for encoding our signal is we are basically multiplying the original data with the chipping sequences. So chipping sequence is nothing but it's a kind of chip code which is the combination of zeros and 1. Then we will going to convert them into polar signaling schemes. That is, for 1 we are transmitting 1 and for 0 we are representing with your -1, and that chipping sequence will get multiplied with the original data. So this is how encoding of CDMA signal will going to take place. For decoding, what we are going to do is the inner product of the encoded signal and the chipping sequence. So we will try to decode our encoded signal with the help of its own chipping sequence. So what we are going to do that we will going to perform the inner product multiplication with the same chipping sequence. So this is how we will be able to decode our signal. So CDMA allows multiple users to coexist and transmit simultaneously with minimal interference if and only if the codes are orthogonal to each other. So what is so peculiar about CDMA systems is it basically allowing multiple users to coexist and transmit simultaneously. So I mean, they are exploiting or using the same frequency band, they are also using the same timing slots, but then also interference will not going to affect them. Please keep in mind that here I am saying that with minimal interference or interference will not going to happen. So one might get the doubt that if in the same time, same medium, same frequency signals are present, then definitely they will going to interfere with each other. That is true. But the point is, in CDMA, we possess the technique that we can retrieve our information signal back from the interference, or in that essence, we could also say that the interference effect will be minimal in CDMA. So when this will going to happen, if the codes with the help of which we are trying to transmit our signal, they are orthogonal to each other. So orthogonality is the special property which allows us to get the transmitted signal back from the interfered one. So each station transmits over the entire spectrum all the time but are not garbled. So this is what we are talking about. Multiple simultaneous transmissions are separated using coding theory. So we will going to make a separate video about CDMA systems encoding as well as decoding process with the help of certain examples. But here, since we are discussing CDMA as a multiple access environment, so we will just going to take the overview how CDMA functions and what are the various features of CDMA systems. So this particular figure is showing the code division multiple access. Again, we will be considering the same example. We will be having these three axes, that is your frequency, code and timing. Please keep in mind that here we haven't divided our frequency or time. All the users are using same time and same frequency, but the division we have formed in our coding axis. So we are actually have provided our distinguished users up to K1 to K6. We have providing them distinguished codes, and what is so peculiar about those codes is they are orthogonal to each other. So this is how our CDMA systems works. So the advantages of CDMA systems are, it is highly bandwidth efficient since code spaces is huge. So obviously it can transmit much larger amount of information. That is why we are calling them bandwidth efficient scheme, and it is dependent upon the number of codes available. Obviously we are talking about your orthogonal codes. So since large number of orthogonal codes are available, so with the help of those codes, highly bandwidth efficient transmission might be possible. So second important point about your CDMA systems is it is almost impossible to jam since we are exploiting spread spectrum communication system. So anti-jamming is inherent in your spread spectrum communication systems. Then larger capacity and low power consumption. So power consumption in CDMA systems is quite low since we are transmitting noise-like signal, which will be having very lesser amount of power, and since large code spaces are available, so many number of people would have been used the common medium. So that is why we are saying that CDMA systems have large capacity. So the disadvantages of CDMA systems are more complex signal generations. Obviously, since we are exploiting spread spectrum communication systems, so the generation and reception, obviously it's quite complex since it is demanding high synchronization in PN sequence. They would have been implemented with the help of using spread spectrum system, which is also very complex. So now the applications of CDMA systems are, it is mainly used in wireless broadcast channels such as your cellular, satellite systems, etc. In present state of art, CDMA would have been widely accepted as your multiple access environment. So CDMA would have been used in interim standard 95, that is your CDMA mobile phone systems, WCDMA, CDMA 2000, etc. So these are some of the examples where CDMA would have been used. CDMA has merged with the GSM technology to have a high speed 4G or LTE internet services. So in the present state of art, whatever 4G systems we are using, they all are exploiting WCDMA systems as their radio interfaces and multiple access environment. So now this particular slide is showing the comparison between FDMA, TDMA and CDMA. So in our first column, we will be having several features. Then in the second column, we will be having your FDMA, third is having TDMA, and fourth is having your CDMA. So if we talk about the feature, high carrier frequency stability, obviously in FDMA, the major role is subband frequency selection. So obviously we will be demanding high carrier frequency stability. That is, we demand that users should in a state to generate their fixed carrier frequency. It will not get altered. So in FDMA, it is very necessary. Whereas in TDMA, it is not necessary just because we are dividing the time axis and the whole frequency band is being available to the individual user. So here it is not necessary, and so is the case for CDMA, since we are allowing all the users to exploit all of the frequency band available. So timing synchronization, obviously in FDMA we don't need any sort of timing synchronization, whereas in TDMA and CDMA timing synchronization is required. Near far problem, obviously we had seen that those users who are lying just near about the base station will going to get high signal power reception in comparison to those users who are lying at the edge or far from the base station. So proper signal reception will going to become a bigger problem for those mobile users who are actually far from your base station. If these users are also receiving some of the signal power from undesired users, so this particular problem would have been called as your near far problem. It basically existed in your CDMA and it would have been controlled with the help of power control technique, whereas in FDMA and TDMA it does not exist. So variable transmission rate, whether it will going to support your variable transmission rate or not. So FDMA, it is quite difficult since we are providing fixed frequency sub channels to individual users. So utilizing those fixed frequency channels, it is not possible to support variable transmission rate. Whereas in TDMA and CDMA, it is possible. Fading mitigation. By fading mitigation, we mean that due to multipath propagation effect, the deterioration exists in the signal or not. So in FDMA, to reduce the fading effect, equalizer is not needed, whereas in TDMA, equalizer may be needed, and in CDMA, with the help of rake receiver, we can perform the fading mitigation. So power monitoring in FDMA, it is difficult, whereas in TDMA and CDMA, it is easy. Zone size, or we could say that the coverage region, in FDMA, we can have any cell size, whereas in your TDMA, it could be of any cell size, but CDMA, if the cell size is large, it will be difficult to handle, just because in large cell area, large number of users will be there, and there might be the chances that in the coding space, we might not find that many number of orthogonal codes. So that is why we are saying that for large cell size, it is difficult. So this is all about your FDMA, TDMA and CDMA. Hopefully now you get the complete insight about channelization, about multiple access schemes as channelization. So in case of any doubt, you can ask in the comment section. These are the references. Thank you very much for your patient hearing.